Hi, I'm Michael Enders from Management Systems Improvement, LLC. We call ourselves MSI. We're here to go over some of the fundamental requirements of AS13100. We had a previous session where we went over the development of AS13100, the whys and the wherefores, the applicability of the standard, most importantly what the schedule for rollout of the standard is going to be. Today, we're going to begin a series of webinars where we explore different clauses and sets of requirements out of the standard, try to dig into them a little bit without doing a real deep dive, because otherwise we'd be here for hours. First, I want to stress to everybody a thing that I always like to open with when discussing the aerospace business, aerospace, space, and defense, is that what we do is important. It's hard to understand when we're manufacturing a little gazinta that it could be a mission critical part. We definitely have lives of consumers and warfighters at stake in just about everything that we do. So it's important for us to understand that what we do is important, and that all the controls, etc., that we put in place are for a reason. The AESQ, the Aero Engine Supplier Quality Organization, has established for itself a vision statement, which is important for us to understand, in that it is established primarily to maintain a common set of requirements that we can all use throughout the aerospace engine supply chain. Up until now, remember that we've had several different sets of standards coming from all of the different primes that we do business with. And the AESQC's mission now is to establish this common set of requirements so that we can have capable processes towards manufacturing these engines, and foster a culture of continual improvement. Real quick about the structure of the AS13000 itself. If you remember, the standard is split up into three chapters, A, B, and C. The first chapter being the AS9100 supplemental requirements. So AS13100 is set up, so AS9100 is the basis document, and then we have all of the supplemental requirements that are AS13100 specific. So you will not see in AS13100 all of the AS9100 requirements. You have to use both documents in conjunction with each other. The second chapter, Chapter B of AS13100, has to do with the advanced product quality planning and the production PPAP process to AS9145. These are the supplemental requirements. Chapter C is dedicated to defective prevention and some of the quality tools that are going to support APQP and PPAP. In addition to the standard itself, AS13100, there are about 12.5 what are called reference manuals that expound upon the requirements in AS13100, more towards guidance and implementation than in absolute requirements. We're going to touch on a couple of those today, the RM13003 Measurement Systems Analysis and RM13007 Sub-Tier Management. All of these reference manuals are available on the AESQC site as well. The requirements that we're going to hit on today have to do with measurement system analysis, which is found under the calibration section, 71511. Control of externally provided processes, products, and services / purchasing under 8.4, specifically with regard to supplier selection and control. And then we'll spend a minute on verification of metallic raw material, 85141. The three requirements that we're going to examine here today apply to all Type 1 make-to-print suppliers. If you remember from the first presentation, we used Table 20 to determine the type of organization that we are. The vast majority of the companies that need to be concerned with AS13100 are in the supply chain as make-to-print. These are going to be those companies that don't have design authority or design responsibility that will be manufacturing parts and so on to customer drawings. Then in Table 1 of AS 13100, we have a list of clauses throughout the standard and how they apply to the different types of company, the type of organization. Most of the requirements will apply to Type 1 make-to-print suppliers, with the exception of Design Control 8.3. And you should have some record of the determination of your company type as part of your scope of the management system, wherever you have it in your documentation and your records, probably in your quality manual. First clause that we're going to discuss today, measurement systems analysis. First off, these requirements do not apply to Type 3 distributor suppliers. Obviously, distributors are not going to be measuring product, so measurement systems is not something that they have to be concerned with. And there is reference manual RM 13003, Measurement Systems Analysis, which has quite a bit of guidance in how to perform measurement systems analysis and maintain your measurement systems. We will not go too deep into RM 13003 today because it's just very, very extensive, but we will touch on it. Measurement system. It's not just the equipment. We think of our calibration program, our calibration system, as being those gauges and instruments that we use to verify the characteristics of our product. But a measurement system actually includes the people, the materials, the measurement methods, the environment within which the measurements are to be taken, and the analysis of the measurements and those decisions that are made on the measured results as to the acceptability of the product and the acceptability of the verification technique. So when we talk about MSA, measurement systems analysis, it's a lot more than just the gauges, if you will. The reason for MSA is that all measurement systems have a certain level of uncertainty associated with them. There are variations in all of the factors that go into a measurement system. There's variations in the environment, variations in the techniques that different people use to use the same instrument, certainly differences in the methods that the instruments are used, where used, how used. All of these factors are going to have some degree of variation. The idea of MSA is to identify the level of uncertainty of the whole system to ensure that the measurement system is fit for its intended purposes, that we are using the right instrument in the right area, in the right manner, in the right environment, so that the measurement results can be trusted. We know that we're getting good results from our gauging systems. MSA will identify the total variation and the systemic error present in the measurement system. And once the variation is known, then we can identify the underlying contributors to these uncertainties. And like we said, there are all these different factors that go into a measurement system, each one of them having its own error of uncertainty, if you will. The more we know about how much each of these factors presents to the overall uncertainty, we can have more effective control over the measurement system by controlling these different factors in different fashions. When doing a measurement systems analysis, it's generally through a series of experiments. We're going to be, for example, measuring a part with 3 different pairs of calipers as one factor. We may measure the same part with one set of calipers using 3 different people. We may ask those 3 people to use the same caliper to measure 3 individual parts all at the same time while we're have another experiment to vary the environmental conditions where the measurements are taken in the calibration lab, maybe in the inspection department, and maybe out on the shop floor. And a measurement systems analysis study, an MSA study, has to be designed so that it reflects real world conditions. We're not creating artificial conditions to try to make the measurement system as reliable as possible, we're trying to measure what the variability is of each of these factors in the way that the factor is going to be deployed. MSA should be conducted anytime we have a new part introduction, an NPI, to make sure that that measurement system is valid and that we can have confidence in the results of the measurement system prior to putting the parts into production. At times, we're going to repeat MSA. These are pretty much under the same kind of guidelines as first article. If we've gone for a certain period of time without doing an MSA, if we've made a change to the gauge design, if we've refurbished or repaired a gauge, say the environment under which we're operating changes, maybe from one area of the plant to another area of the plant, or we're going to be measuring parts at the receiving warehouse where it's different from measuring it in the inspection department where it had been. And certainly anytime there's a product change to any of the features that are being measured, we're going to have to do another MSA as well. There's a chart in the reference manual. We'll put it up here. Table 2. Okay. Anyway, at table 2 of AS13100, we have a very functional picture of the conditions under which we're going to apply measurement capability and assessment. An example that we've picked is that for a particular characteristic, we have to determine what its classification is, critical, major, or minor. Then the event description in the chart is going to tell us, for example, we have a new verification device or a new verification method that we want to introduce. The chart tells us that for a critical characteristic in our example, where we're implementing a new verification device, this is a mandated MSA event. So we do have to do a measurement systems analysis if we're going to introduce that new gauge and record the results, of course. And there are different levels of events that we will have to consider redoing an MSA. For example, as part of a first article, if we haven't done one in a couple of years, most of those requirements are that we're going to do an MSA at the whim of the customer. So we have to present to the customer the need for the first article inspection and get from them their determination as to whether or not we're going to do a new MSA. In doing an MSA, there are some system requirements that we want to have in place. First is we're going to nominate someone to perform the product verification activities. These are going to be our inspectors, our operators. These are the people that are actually measuring the product on an ongoing day-to-day basis. These people have to be trained and competent. Beyond that, we have to make sure that any MSA experiments that we run are in alignment with industry recognized techniques, and the reference manual 13003 MSA has techniques in there that if we follow, we will not have any issue. If there are any critical characteristics that are identified on customer drawing, customer requirements, those are all subject to an MSA. Whenever we are doing an MSA, we have to make sure that the parts that we're using are representative of the process, the tolerances, the dimensions, etc. Just as when we're doing a first article inspection, when we do an MSA, we have to use actual production-based parts. When we're doing the actual testing, we don't want the people involved in the test, other than the moderator, to have any visibility to the study results. That could bias the measurement systems analysis in one fashion or another. So these are all relatively blind tests. We are going to design these experiments, again, giving one person a particular instrument to measure particular parts with, and then recording the results and not sharing those results with the participant. And then through statistical analysis, we want to make sure that the results show stability, process capability when we're done. There is another chart in 13,001 that describes the different characteristic classifications and the levels of capability that we have to use or have to verify during our measurement systems analysis. This is on table 4. And this shows for those critical, major, and minor characteristics, different requirements of the measurement system and what the limits are of those different factors. For example, the accuracy of a measurement system has to be at least 10 to 1, and for critical and major characteristics. If we have a minor characteristic, then the accuracy ratio can go down to 4 to 1. I think all of us that are in AS13100 world recognize the 10 to 1, 4 to 1 requirement. We have requirements for repeatability based on the characteristic, critical, major, or minor. Repeatability has to be equal to or less than 10% of the total tolerance for critical characteristics, all the way up to 30% for minor characteristics. And then we have requirements for appraiser consistency, the appraiser to appraiser, and appraiser to standard experiments, so that when we do see these variations from one gauge operator to another gauge operator, we can quantify those and determine if those are also in limits to table 4. Every company should have someone identified as their practitioner, as the standard refers to it. This is the person that's responsible for developing and moderating the measurement systems analysis experiments. This person has to have adequate competence levels, experience and qualifications in all aspects of MSA. The practitioner is also responsible for driving throughout the organization the correct behaviors and the training, etc., that will lead to effective implementation of the measurement system. We know that we have management and we have supervisors and training of employees and so on, but we've also given additional responsibility to this practitioner to develop techniques, training, awareness, etc., in how to use the measurement systems. And it's responsibility of the practitioner to periodically confirm the organization's compliance to MSA through some oversight and testing, etc. Anybody that is going to be involved in the MSA, of course, is trained and competent in the measurement tasks that they're performing. And they should be representative of the different people that are going to be using the measurement system. So, for example, if you're going to be evaluating as one of your factors the inspectors as a whole, then you'll pull from the inspector pool someone to participate in the experiments. You may have multiple people that you choose, but same thing when you're choosing operators, is choose from the operator pool. The idea is not to cherry pick people that are very, very good at using a particular instrument, for example, but anybody that will be required to use that equipment is subject to the experiments. The facilitator will lead the experiments, make sure that they're conducted appropriately, make sure they're conducted in accordance with the plan, make sure that there are no extraneous factors that are being brought into the measurement system analysis that would invalidate the results. We're going to document the competencies in measurement systems analysis. So we would have some kind of records of the experience, competence, training, etc., for inspectors, for operators, certainly for the moderator. Anybody that's involved in specifying the gauging system or using the gauging system or in verifying the gauging system has to be competent, and we have to have appropriate records for those people. I think that's all we have to say about MSA without getting too deep in the weeds. If there are any questions, you can send them in to msiaqr.com. If you go onto the website, there is a button there for asking questions. So we're going to move on to 8.4/purchasing, specifically supplier evaluation. Throughout the standard, especially in 8.4, basic terminology needs to be determined. We have a customer. That's who is buying from us and who is imposing these requirements on us. We would be known as the organization. We are the body that is fulfilling the requirements, and anyone that we use below us to perform services or from which we buy products, materials, whatsoever, the standard refers to them as supplier. So as we go through here, those three terms, customer, organization, and supplier, are going to be used. I also like to point out that for the term supplier, we also interchangeably use subcontractor and vendor, especially if you've been around for a while. But not to be confused, customer, organization, supplier are the three terms that we're going to be using here. Before we approve a contract or submit an order to any supplier, we have to conduct an evaluation of the supplier. We all understand that. It's kind of a given. I think that it's maybe honored in the breach. We probably don't do enough supplier selection discipline as we should. AS 13100 specifies more strict controls over the selection of suppliers and how we manage our suppliers than does AS 9100. I think that we might find them a little bit onerous, especially for the types of shops that we're talking about, the make-to-print shops. However, it's important. Managing the supply chain, as we all know today, is very, very important. And AS 13100, even before the current difficulties, recognized that there were issues in the aircraft industry with the supply chain. And we have to make sure that we understand our responsibility somewhere in the middle of the supply chain to manage that part of the supply chain below us. So we're going to have some level of evaluation for the suppliers that we determine we're going to do business with. That level of control, that level of evaluation that we apply to suppliers is going to be based on risk. How much of a risk does the supplier present in terms of itself, in terms of the products that we're buying from the supplier, in terms of the process that the supplier is going to be performing, in terms of the expectations that we have of the supplier. So we would want to be able to demonstrate for our supply base that we have structured the supply base on the basis of risk. Whether we have a global risk analysis of all of our suppliers, whether we do commodity risk analysis by the types of things that we're going to be buying from different suppliers, whether we do a risk analysis on individual suppliers one by one, is not as important as being able to demonstrate that we have arrived at our supply base using risk analysis as one of our tools. One of the requirements of AS 13100 is that we have to do an on-site evaluation of a supplier candidate if significant risk has been identified by our risk analysis. And this standard goes into a lot on what goes into the on-site evaluation that we're going to perform. So this is the flow of supplier evaluation in the standard. We're going to define the criteria in step one for the parts, the commodity that we're buying. What's the material? What's the part? What's the tolerance? What's the volume? What's the acceptable quality levels, if you will? There's a lot of information that has to be determined as to what it is that we're going to buy. We're going to prepare some kind of, let's call it a questionnaire, because that's what it's called in the standard. This is less a questionnaire, I think, than in a process that you have for how you identify and evaluate suppliers. Included in this process can be your risk analysis and your decision-making process for who gets an on-site visit, who does not get an on-site visit, what level of evaluation is performed for which types of suppliers, etc. A good supplier selection and control process is important at this point, and this will give you the switching rules for when it is that you're going to do an on-site evaluation. Then you're going to conduct your on-site evaluation. Based on the results of the on-site evaluation in step 2, you're going to identify and analyze any risks that were uncovered during the analysis of the supplier. Do they have the technical capabilities to deliver what we want? Do they have the financial ability to deliver what we want? Is there enough personnel, trained personnel on hand? Do they have the proper equipment, etc.? So you're going to do a pretty good analysis of the supplier and its capabilities and identify and analyze any risks that come out of that. And then, of course, you're going to come up with a risk mitigation plan for any high-risk factors that are uncovered as part of this assessment. You're going to approve the supplier in step 3 on the basis of the assessment. Identify the scope of work that the supplier is approved for, and you're going to put the supplier on your qualified supplier list, your approved vendor list, AVL, whatever it is that you use for your record of approved suppliers. The evaluation has to be based on minimum of 4 significant factors. Their engineering and manufacturing capabilities. Can they manufacture the product, and can they control changes to the design and the processes? Their quality control capabilities have to be assessed. Will they be able to meet the quality requirements? The third assessment is their purchasing planning and capacity. Can they handle the orders that we give them? Can they handle the orders, the volume that we plan for them in the future? And do they have an adequate management of their own supply chain underneath them? And then the fourth factor is commercial, legal, and environmental requirements, especially regulatory business requirements. How is the company being run? Are they paying their taxes? Do they have any recorded liens against the company, et cetera, that would create risk factors for us as their customer? And all of the evaluation criteria for the above 4 are going to be found in RM 13007, the sub-tier management reference manual. There is a supplier selection capability assessment model, SSCAM, that's referred to in the handbook. I couldn't find it. They say that it's on the in the supply chain management handbook, SCMH, that's on Oasis. I spent a lot of time looking for this thing, and I can't find it. I guess the long and short of it is that there's not a real tool out there that you can use that's put out by the aircraft industry to use in assessing a supplier, like the supplier questionnaire, if you will. There are a lot of good tools out there where you evaluate different aspects of the supplier system and capabilities, et cetera, and score them out and get your red, yellow, greens and action items and so on. But I just could not find the one that they refer to in the handbook. We'll keep looking for it. Whatever the case, whatever tool you use, you're going to maintain a record of the assessment that you did against the supplier. This is super important. Even if criteria is not considered relevant, have a record that you decided that it was not relevant and if supplier was not selected. But certainly for any supplier that's on your ASL, your approved supplier list, make sure that you have some record of an assessment that was done on them, even if it was just a desk assessment. We'll also have to flow down ISO 9001/AS9100/NADCAP certification accreditation requirements to our supply chain. This appears to be an absolute requirement of AS13100. There is a chart, table 2, in the standard that shows for the different types of companies what the minimum registration requirement is. For example, for all the type 1s, which is primarily to whom we're speaking to today, AS9100 registration is a minimum requirement. And it goes down through the different types, identifying the registration accreditation requirements, including for special processes companies. They all have to be NADCAP. Calibration labs or other laboratories that we use have to be ISO 17025 accredited. Even raw material suppliers have to be minimally ISO 9001 registered. So given that, we have to have a system in place for monitoring and verifying the registration status of companies. That's usually done through the approved supplier list. That's what we found to be the easiest way to do that. But it requires ongoing monitoring, and it's not as simple as you get a copy of a cert, their ISO or AS9100 registration cert at the time that you start doing business with them. There's a requirement to continually ensure that the company maintains its registration status. Fortunately for AS9100 companies and for NADCAP companies, there are databases that are available to us where we can regularly go in and verify the status of suppliers working for us. When it comes to ISO 9001 suppliers, for example, that's way more difficult. A little more research has to be done to ensure that a supplier company maintains its registration. Now, there are some requirements that in AS9100 I refer to as optional. Those are in 8.4.3, information for external providers, where we are required to communicate to our external providers our requirements for, and then there's a whole list of all of the flow-down requirements. Now, we've been arguing with auditors for years that the phrase, the organization shall communicate to external providers its requirements for, means that we don't flow down all of the requirements to all of the suppliers. We only flow down the applicable requirements to each supplier for each order. However, we've received enough non-compliances over the years that our terms and conditions of purchase document does not have every single one of the bullet points in 8.4.3 listed. So the argument that we don't have to give every requirement to every supplier on every order has been made moot in AS 13100 in taking a whole bunch of those requirements that were in 8.4.3 and making them more mandatory, if you will. Some of these include that that the supplier's certification has to be defined in accordance with the organization type and comply with Table 2. So there's no more with us being allowed to have a plan for development of a supplier's quality management system. The supplier's quality management system must be registered in accordance with Table 2. Suppliers now have to have an effective FOD, foreign object debris, foreign object damage prevention program. No longer can they do it as they see fit. It's mandatory by AS 13100. Likewise, suppliers also have to have a counterfeit parts program, and it has to be in accordance with AS 6174, AS 5553, whichever one is going to be applicable, mechanical and electrical. The supplier's counterfeit parts program has to be formal, has to be documented, has to be implemented and verified, and it has to include a mechanism for reporting any counterfeit parts identification to our purchasing organization within 3 days of it being confirmed. So this, again, no longer optional that suppliers have counterfeit parts programs. And the suppliers have to notify us of any significant changes in their management system or in their business operations. Supplier has to comply with our specific requirements for control of work transfers. That places a lot more control on us as the organization over the supplier subcontracting our work further down into the supply chain. prevents brokers, if you will, from taking our orders and then just passing them on to whoever it is that they can see fulfill those orders. So before a supplier can transfer any work from them, they have to get our permission. And if there are any restrictions to right of access to a supplier, facilities, information, records, whatever, we have to have a risk mitigation process implemented to determine what that means to us and how we're going to get around that. In any case where we have had our customer delegate verification activities to us, we can only flow that down to our suppliers with the customer approval. So just because we have been delegated to, we cannot therefore flow down delegation to our suppliers. We got to go back to our customers, and get permission to do that. And then in the case of us being allowed to delegate verification activities to our suppliers, the training for those self-release delegates at our suppliers has to be as robust as that expected on us by our customers. Material testing, material and special process testing. We've all received these certificates of conformance, the CFC, which pretty much says for purchase order, whatever it is, I gave you whatever it is that you asked for. Those are no longer acceptable. We need to have actual complete test results on test certifications, and all of the requirements that are on the drawing, in the specifications, have to be in conformance or otherwise clearly stated on the certificate, given the examples that are in the standard. So we have three conditions when we get test results from our suppliers. Either the cert lists all of the requirements and states that all of the tests and inspections have been performed and the results meet the requirements, or the tests and inspections have been performed and everything is okay except for these characteristics which do not meet requirements, or all the test inspections have been performed except these which were not performed in accordance with the drawing and or specification requirements. So your acceptance of test certs and raw material certs is going to have to be a lot more robust. Your examination of these certs that you get from the supply base has to be a lot more robust, and the certs that you will be examining have to be far more complete than they have been in the past. We also have stamp control that's flowed down in AS13100 as part of our purchasing processes, which means our suppliers have to have stamp control. And this applies to electronic signatures, et cetera, and passwords. So they have to have a process in place for managing whatever the media is, to avoid the misuse of stamps, for example, misuse of the passwords, establishing traceability to the user of the media, avoid duplication, make sure we don't reissue the same stamp or people aren't using the same passwords. Make sure that people have the proper authorities with regard to the media controls, and that the media controls, especially stamps, are maintained in good condition and legibility. So where we may have had stamp control processes of our own, it's now mandatory that they be flowed down to the supply base. Supplier surveillance, it's a lot more strict under AS13100. We're actually going to monitor our suppliers. We're going to use KPIs. We're going to be using results, and we're going to be feeding those results back to the supplier with the intent for the supplier to correct when is necessary. One of the bases that's used for appropriate surveillance to monitor a supplier system is going to be an audit. That's described in more detail in the reference manual 13,005, the quality audit methods. I think that we can still monitor our suppliers, supply scorecards, measure the KPIs, etc., on the basis of the 80-20 rule. The one supplier that we bought $50 worth of stuff from late last year, we don't have to do scorecards on them, I don't believe. But certainly 80% of your buy has to be subject to these monitoring controls, measurement, KPIs, and reporting back to the supplier on their performance. We have to provide these monitoring results on a regular basis. The standard suggests annually. I hate doing stuff annually. By the time annual rolls around, the damage has already been done. Perhaps you can have an internal monitoring process where on an ongoing basis you're keeping track of your supplier performance and then only report to them annually. Maybe that would be acceptable. But I would not wait until January of the following year to do an analysis of our supply base and develop KPIs and scorecard results on the basis of last year's results, because again, the damage is already going to be done. So have some kind of an ongoing monitoring system, even if you're not reporting back to the suppliers their results except once per year. For any suppliers with unacceptable performance, of course, the monitoring review is going to be held more frequently. Any of the suppliers that are in trouble, they can expect more attention from us. If we experience unacceptable performance from a customer-specified supplier, we have to let the customer know right away. They have some level of faith in these suppliers that they're specifying, and they want to maintain that faith by knowing that the supplier performance has been adequate. And in any case, if you have a supplier that is not fitting the bill, is not meeting its performance requirements, some corrective action is going to be necessary. If that corrective action proves not to be effective and the supplier scores don't come up, then you've got an escalation process that you have to implement and ramp up the efforts to improve or get rid of that supplier. When it comes to the information for your suppliers, you have to determine that they have a system for understanding your contract requirements and that they can flow the applicable requirements down through their end of the supply chain. So whether it's a combination of audits, gauging their process, receiving confirmations, order confirmations from them, or auditing their supply chain, you want to make sure that they can adequately flow requirements down through their supply chain. And the reference manual 13007, Subtier Management, gives a lot of information on how to manage that. The last quick subject here is verification of raw material, metallic raw material. We've been relying on these material certs that we get from raw material vendors as the basis for accepting the material. AS13000 now requires us to have a process for us to verify the metallic raw material before we put it into production. The metallic raw material testing requirement in AS13100 is not meant for the material suppliers themselves as a means of determining if they have the right material. It's for us to determine at receiving, if you will, that the supplier has given us the correct material. We have to use handheld spectrometry devices. I think we've all used the alloy type testers, the handheld alloy type testers before, and we have to verify 100% of the material coming in. If we do sampling of the material, when we get high volumes of material, that's acceptable as long as the sampling plans that we're using are zero-based acceptance, and that they are industry approved, if you will. That's all that I have today for specific AS13100 requirements. We definitely will have ongoing sessions because, especially for Type 1 manufacturers, there are a lot more requirements to dig into, but we don't have quite the time in one presentation to do all of that. So I thank you for your time. Again, if you have any questions, my email is mpenders@msi-aqr.com. We also have a PowerPoint presentation I think that we can somehow make available either on the YouTube or on our website for sure, that will kind of mirror the presentation today and hopefully give you a little bit of information. Hope you found this helpful, and we look forward to seeing you at future presentations. Thank you.